Okay, so what I want to do in this video is to create a little bit of clarity around this volume of solids and revolutions and how that works. In this next video that you'll see that we dive deep into the questions, but I thought it's worth it just taking some time explaining this. So when we're dealing with functions, let's deal with this diagram A. When dealing with functions in the xy plane, you'll see we've got a function over there, and obviously it creates that particular shape and where it's shaded, and that's how it looks like. So once you start thinking about creating a region around the x-axis, we can turn this into like a 2-3-dimensional looking shape, and this is exactly what it looks like, and therefore we'll call this diagram B. And normally between diagram diagram A and B, that's where we do our integration and we can find the area under the curve. What I want us to feast our eyes on now is this whole idea of a solid of revolution. So think about the very same function, sorry for that, the very same function now rotated 360 degrees around the axis there. So that creates a 3-dimensional shape, and we call that the solid. And because it's been rotated 360 degrees around the x-axis, we call that a solid of revolution. So because now this is a 3D shape and it's a solid, we can calculate the volume of that. And the volume of that is likely given to us, it's pi over the lower boundary, the upper boundary of now the square of the function dx. So that's how we'd be able to calculate that particular volume. So let's look again at more examples. Normally you'd be given a parabola like that, which is x squared minus 4x plus 5. In just a basic 2-dimensional shape, it looks like this diagram A over here. It's bounded between 1 and 4. Whereas if you were to look at it, if it is just rotated around the x's, it'll look like what diagram B is looking like. And if it was rotated 360 degrees around to make a 3-dimensional solid, then we are basically trying to find the volume of this bounded between 1 and 4. And therefore, the formula for this when calculating the volume would be pi going from 1 to 4. But now it will be of the expression x squared minus 4x plus 5 all squared. And then by us integrating that and multiplying by pi, we are essentially finding the volume. Let us look at one more example. If you had an expression like this, 1 over x in this diagram A, bounded between 1 and 2. In the normal 2D space, x and y plane, it just looks like that. But if you want to create a solid out of it where we can find the volume, you can think of, or you can try picture this in your head. This is the volume that you're trying to calculate. So this is the shape that you're trying to calculate its volume in this diagram B. So whenever you're dealing with questions of solids of revolution, so where you have to calculate volume, be able just to picture in your head or understand you're not calculating the volume of just the 2D shape, but you're calculating the volume of the solid that is formed in the 3-dimensional space. I hope this makes sense. So please have this idea in mind whenever you are solving the questions that are coming in this series. See you in the next video.